Please take your seats. Our program will continue any moment. Please welcome back to the stage today's MC, Senator Brenda Stanley.
Thank you. Welcome back, everyone. Our next guest is the director of the Propulsion Directorate for the Air Force Life Cycle Management Center. Please welcome Mr. John Sneden.
Well, how is everybody? Good, all right, yeah, let's talk some propulsion stuff, yada, 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 okay. So, I gotta tell you, I love being here. I think this is just a great forum. It's an opportunity for us to share, for us to exchange a little bit. And so I'm gonna kind of walk you through how I see the propulsion challenges, where we need to get after some things, and hopefully leave a little bit of time for some questions at the end. But before I hop in the deep end of the pool, I just want to give a shout out to Erica Cook, who's doing all this closed captioning that you see here, hopefully below me. Yep. And so it's not a fleet of teenagers back there texting. It's Erica, and she's doing a fantastic job. And I also want to apologize to Erica, because when I get off on a tangent, it could be a really bumpy road for both of us. So we'll see where this goes. All right. So I just want to start off a little bit with about us. You know, what is the Propulsion Directorate? In a nutshell, we are the center of excellence for all things propulsion. We act as that single doorway for all propulsion matters. I have a very diverse portfolio that ranges from developing new engines for the next generation air dominance fighter to sustaining engines that were frankly fielded in the 1950s, early 1960s, so very diverse. We support 10 MAGCOMs, 51 international partners, and I have a team of over 600 propulsion professionals who do just an outstanding job. They're just real superheroes. Some of them are sitting right over there, so you guys raise your hands. Okay, not you, Chris. All right, but I will tell you that everybody who's involved in this community absolutely believes in what we do. They love generating that sound of freedom 24/7, 365, and we all value you as partners in this business. So I know many of you caught the Secretary's comments a little bit earlier today, and as he continued to emphasize the 7 operational imperatives and our predominant focus of China, China, China. And from a propulsion perspective, 3 of the imperatives kind of come naturally to the forefront. Number 3 and number 6, defining the NGAD family of systems, defining the B-21 family of systems. And I'll just broadly offer that whether you're talking about the NGAD fighter, B-21, collaborative combat aircraft, that there is no next generation air dominance without next generation propulsion capabilities. And together with our industry partners, we are working on developing those systems so we can field it in support of the warfighters. Well, what I want this particular audience to focus on is OI number 7, readiness to a wartime posture against a peer competitor. It should go without say, but I'll go ahead and say it anyway, that fleet readiness and propulsion readiness go hand in hand. And to get there, you have to have a responsive and capable propulsion industrial base and supply chain that can yield the results that we all need. And it ultimately has to move at a threat-relevant cadence. And to get there, you have to overcome a sundry of challenges that this community has essentially kind of indoctrinated into its nature over time. And I'll talk a little bit about what those challenges are, but again, this is something that we have to kind of get at together. How do we move that industrial base? How do we move our supply chain? How do we move all of our efforts forward so we're moving at speed and scale across all of our endeavors? So I typically kind of start this place and it kind of turns into a oh no, the sky is falling, so I'm just going to start the propulsion challenges discussion with a little bit of good news. Okay, so let's put this in context. Together, we, our predecessors, the people in this room, have crafted the world's most effective propulsion defense industrial base, and it fields, develops, and sustains the most ready, the safest, and the most effective military propulsion systems in the world, okay? And that's a big deal. And I will also share with you that as a result of that movement, we have sustained, maintained our propulsion dominance for decades upon decades. So I just want to kind of drink in that moment because that is a significant challenge that we've all gotten here together, okay? But as the saying goes, the things that got you here probably aren't the things that are going to keep you here, okay? So we need to start thinking about how do we step up our game, because as the Secretary of the Air Force indicated earlier, again, the focus is on China. It's not what's worked over the last 30 years. It's not what's worked over the last 50 years. It's what is going to work against China. And the time I will offer to you is now. It takes this community a long time to move forward in terms of being able to yield propulsion solutions, be able to develop capability. So we have to start moving forward now. And frankly, if we fail, then we will lose the propulsion superiority that our warfighter has counted on for, since at least the Korean War. And I will just offer to you that is not acceptable. And I know you all join me in that perspective. And I'll share with you that we are losing the propulsion lead to China. And it's through reduced investments, reduced technology transitions, and frankly, reliance on status quo approaches that threaten readiness. And meanwhile, China is investing substantially more than we are right now. They're closing the propulsion gap through fielding of capability, closing the propulsion gap through investing in their industrial base. They're catching up. And we have to do something different to be able to drive the right outcomes. So, and again, I firmly believe this propulsion industrial base is an extremely capable one. But when I talk about declining industrial base responsiveness, what I mean is that we are not moving at a threat-relevant cadence, okay? And, and I frequently have this discussion with my industry partners, and sometimes the discussion is that nothing needs to change, nothing needs to move, but it does need to move. China is catching up. And why does it need to catch up, or why do we need to make the shift? Well, if you start thinking about how long it takes to get a developmental system out in the street, 10 to 15 years from inception and funding of the requirement forward. So think about what General Richardson offered this morning in terms of how fast China is moving their technology out the door, roughly 7 years. And then when you get on the sustainment side and you say, I have a surge and I need to be able to feed that surge quickly, the answer is, and by the way, I think that the government is equally culpable in this because we really haven't levied a requirement to you. But the answer is that we'll get back to you in 24 to 36 months. That is the answer that we're giving our warfighter customers right now, is that as soon as we need to go surge, as soon as we need to go faster, we'll get back to you in 3 years. It's not acceptable. So we have to start kind of shifting that paradigm a little bit. And one of the ways that you do it is through the implementation of digital tools and technology transition, and that helps us move at this threat-relevant cadence. I've had some of my propulsion partners ask me, why should I? Why should I go ahead and invest and move into that type of technology? Why should I do it? Everything I'm doing right now works fine. And again, what I would offer is that one, the warfighter needs it, and two, as we make these transitions, as you move into the digital transformation type of a world, what you're really finding is that your costs go down, your speed goes up, and that is highly valuable in terms of winning contracts and moving yourself forward. It makes you relevant in this type of environment. So I think that type of investment is really key. And all of this gets, addressed in the big ribbon of the budgetary issues that are out there right now. So post-COVID dynamics, aging fleet issues, competing priorities, worldwide inflationary aspects, the list goes on and on and on. And what that means is that even if budgets stay static, that our buying power has been reduced because it actually costs us more to do essentially the same thing. So at this point, I need more cost-effective solutions to help drive those right outcomes. Okay? But again, none of these challenges are unique to industry. They're not unique to government. They are shared problems, shared challenges that we have to get at together. But ultimately, what I need everybody here to do is have our Houston, we have a problem type of a moment, and I'll wake up and realize that we're not where we need to be and start striving to move to that appropriate spot. And then from a propulsion directorate perspective, all this manifests very cleanly into what we ultimately need to go do. We focus on ready, affordable, safe, and effective engines. And if you're going to bring propulsion solutions to the forefront, this is exactly where I need it: ready, affordable, safe, and effective. And when we measure readiness, we don't measure readiness as in terms of what we need to be able to go fight in the operational environment that we have today or for the next year. We're forward-looking and looking at what it takes to actually go fly, fight, and win in a wartime type of environment. We have to get readiness up. Affordability, we have to be able to drive this to more cost-effective type of solutions. Safe, it's an area that we will never sacrifice. How do we keep our systems the safest in the world? And how do we maintain that propulsion edge through the most effective propulsion capability out there? And I will offer that on the effective side as you're developing new systems. Those things kind of go hand in hand. You get the most effective system out there. But the problem is that many of our systems are all legacy systems that were fielded in the 70s and 80s. So how do you get those up to the effectiveness bar that you really need to be able to take care of the mission today, especially when we haven't done major performance improvements in many of those systems to date? So a lot of work remains in front of this community, and again, I think we're all equal to that challenge. Okay, so how do we get after this? To get where we need to be, the propulsion enterprise needs a digital transformation. Propulsion Directorate's driving that transformation across the life cycle to reinvent how we do business. But to exploit the full potential of our capabilities, we need to design, develop, modernize, and sustain propulsion systems in an integrated digital environment instead of those silos that drive inefficiencies, cost escalations, and frankly, decades to deliver capability. So think again what General Richardson offered this morning. Digital material management. We all have to lean into this and do that transformation so we can continue to fly, fight, and win, both today as well as against the future challenges that we'll have. And I threw this chart in here just simply because I wanted to talk a little bit about what's in the art of the possible. When we do lean into this together, what is it that we're able to achieve? And two key examples on this one. The first one is that we're doing the world's first propulsion digital twin, military engine digital twin. We're doing it on the F-100, F-15, F-16 engine. And as we do that, it's starting to open up some real possibilities. So right now, much of the data that's available to us are all in 2D drawings. So think about how difficult it is for a manufacturer to make a component off of a 2D drawing. That's how we're doing business today, in the past. So as we move through this digital twin, we will have 3D drawings. And when we get 3D drawings, it starts to open up repair and repair development type of ecosystems. So instead of relying on new components, we can potentially do more repair or look at alternative ways to make a part. That starts to combat diminishing manufactured sources type of issues that we have. And it even can take you into a realm like doing virtual reality. But all that's coming through a partnership that we established with the National Institute of Aviation Research to get to our first digital twin, okay? So there's one digital example, and think about how much that will feed over time. The other one is our advanced manufacturing and repair ecosystem. Very proud to state that we have established great relationship with industry to be able to develop, field, certify as airworthy additive components. We're flying those in military aircraft today to include the F-16. And our intent, we've even moved into this window where the Tinker Air Force Base can begin to manufacture their own components. But together, as we all move through this, the intent is to start doing components of higher and higher complexity. So think about it, and if we have a propulsion system that's from, let's say, 1960s, 1970s, and the industrial base has started to dry a little bit, then being able to additively manufacture a component becomes a huge deal. I'm not fighting diminishing manufacturer sources type of issues. So being able to get to that type of speed and scale in the additive world is a tremendous value for us. We've also been able to implement many repair technologies, so instead of having to rely on a new part coming in, which is typically very expensive, I have some components that cost up to $1 million a piece. And instead of having to rely on that, we can just repair those components. And again, speed goes up, costs go down, readiness goes up, and it's a huge benefit to the warfighter, okay? So whether we're talking about digital twins, advanced manufacturing and repair type of ecosystem, what you're finding is that these things really work, and it helps us move at the speed and scale that we need, and it starts to tackle, from a sustainment perspective, the things that we're talking about that are actually slowing us and being able to move at a threat-relevant cadence and against a fight, against a movement towards China. So very important for us. I threw this in just to kind of, help you answer questions about, where you can get involved. I'll just offer, we're open to anything. The more you bring forward to the forefront, the better off the exchange is going to be. But I hope what you're picking up is that I'm really not interested in a lot of tactical movements. I'm not interested in doing business like we always have, and I understand that we're always going to ride that out a little bit. It's always going to be just kind of a natural part of the business. But what I'm really interested in is how do we transform? How do we lean into this stuff from a speed and scale perspective? So anything that accelerates sustainment technology maturation and transition is a good thing. I want to hear your ideas. Please bring them forward. So, there's a handful of ideas on here, from advancing IBR sustainment repair technologies, advancing inspection techniques, so it can help improve decision making, help us ensure that we're keeping our system safe, advanced manufacturing like I talked about on the previous slide, or even maintenance modernization like using virtual reality. All of these things help our sustainment community move at the pace that it has to be able to move at to be able to feed the fight, okay? And again, I'm open, and treat the Propulsion Directorate as your single doorway into those type of activities, and together we'll start to take those next logical steps. I've got a couple slides in here on the industrial base I just wanted to chat with, and again, I'm trying to really emphasize how critical the industrial base is to us and its efficacy. It's paramount to be able to get to the results that we really need. But I need a healthy and robust industrial base, and ultimately we have to kind of get after the known issues that we have, and also those unknown vulnerabilities. And to do that, we've kicked off a propulsion industrial base study. And the objective of the study is to identify and analyze investments required to ensure the long-term viability of the industrial base. More specifically, what we're really trying to do is ensure that we're poised to maintain our technological superiority, increase readiness, and position ourselves to rapidly develop, field, and sustain propulsion technology in support of the warfighter. So what is it that is off with the industrial base? That's really what we're trying to figure out. It could be from where we get our material, there could be risk there, or it could be things just that are kind of becoming an inherent part of the way that we do business. For example, we may be relying on too few forging houses, or other limb facts that kind of propagate through the entire, through that entire community. But what we're really trying to figure out is where are the risks at, and then how do we prioritize those risks? How do we monetize those risks, and then start to get after the things that will really help drive outcome and put that into the budgetary process? So ultimately what we're doing together is that we're trying to figure out where we really want our propulsion industrial base to be in the long run, and then how do we budget for that and get after that so we all have the right propulsion industrial base for the future. And then the final one I'll add is we're very interested in new partners. Okay? And we tend to kind of focus on just a handful of the primary partners here. In our day-to-day business, typically at the OEM level of the propulsion systems that we support. But what we're trying to do here is really open that aperture up. So we're putting forward our second other transactional authority vehicle. It's part of our propulsion consortium initiative. We call it PCI 2.0. And really what the intent here is to tackle problems together. Okay? And this isn't, what we've done is we kind of started to open that aperture up a little bit to where it's not just the Air Force that we're concerned with. Instead, what it is it's the DoD propulsion industrial base. So we're doing this this activity in concert with the Army and Navy. So this will be Army, Navy, and Air Force kind of looking at this from a propulsion industrial base perspective, and bringing in new partners, small business, venture capitalists, anybody who wants to play or can play in the propulsion environment. We want you to come in, and ultimately what we're trying to get after are the things that are plaguing us. How do we do digital transformation? How do we do that consistently so we're all moving together and not moving in disparate ways? Big data analytics, whether it's on engine health monitoring or on use of AI to do better RCM type of activities. Small engine needs, industrial-based risk evaluations, the list goes on and on and on. But this is a vehicle for us to use to explore those territories together. If you're not already a member of the Propulsion Consortium, I highly suggest that you become one so we can help shape the future together. Okay? All right, and then again, in just summary, I just want to offer that I appreciate the partnership that I experience every single day. This community is highly focused on driving ready, affordable, safe, and effective propulsion solutions to its customers, ensuring that the warfighter has what it needs today and tomorrow. And we can't get there alone. So I appreciate everything that you all are doing to help drive those right outcomes. And again, I'm looking for your strategic solutions and how we start to transform this in alignment with what the Secretary of the Air Force has asked us to do, which is yield a better outcome and be ready for the fight. Okay? And we're not there today. So let's get there together. All right, I think I've got about 10 minutes left. And I'm happy to entertain any questions that you may have, whether it's on the app or otherwise.
Just raise your hand and we will come running for you if you guys got one. Awesome.
Thanks. So you mentioned a 36-month kind of lead time to respond to a surge. What were the factors behind that? And is that true for legacy programs or also the new or both?
It's true for all, including legacy. It's not on the uncomplex components. It can be, if the industrial base is dried, but it's typically on the more complex components like blades, for example, and those components take an exceptionally long time to get, and unfortunately, I also mentioned that I think this is a little bit in terms of the Air Force's responsibility, because industry buys what we ask them to buy, in fairness, right? So if all of a sudden that requirement goes up, well, they haven't bought the material, they haven't pulsed their, their sub-vendors to be able to drive those outcomes. So this is a shared problem, but typically when we see 2 to 3 year lead times, it's on complex military engine component parts. Does that address your question?
Okay, sir, we've got one on the app for you. What makes managing engines more difficult? The craft of building engines, the cost of sustaining engines, or the lack of competition or perceived lack of competition that exists for engine sustainment?
So can I just, press the easy button and just say all of those? On the developmental end, so let me kind of break that up a little bit. So the developmental end, as we're looking at requirements for, next generation air dominance, all of a sudden, range becomes a huge issue. Thrust capabilities go way up. Your power thermal management capabilities are far beyond what is currently asked for in legacy systems today. So that means new technology, new ways of understanding how we move those systems forward, and unfortunately, it also means high cost and long lead times to get there. One thing that we're doing on the developmental end, and this is on the next generation air dominance engine program we call it NGAP, is we've actually asked them to make those systems in a digital environment so we can move from a developmental perspective at a threat relevant cadence. But the technology makes that extremely difficult. And then on the sustainment end, what ends up being our most problematic issue on any given day is the age of the systems that we're dealing with. Most of our technology was fielded in the 60s, 70s, 80s, and so we're carrying those out for much longer than anticipated. And as a result, in some cases, if it was based off a commercial variant, that commercial industrial base may have dried up, and we may be trying to revitalize it. And in other instances, it's just hard to get components because we're prioritizing, next generation systems or newer systems over old systems. We may have lost some critical skills. So it becomes very complex on both ends, and I wouldn't say one is more difficult than the other. I would say they're both challenging their own way. And to the sole source piece, I would just say that the Air Force made hard decisions along the way, and those hard decisions sometimes yield the type of environment that we have right now. We always would love to have more competition, would love to have, multiple engine vendors for every airframe that we have out there, but that's not the reality that we live in. We live in a resource-constrained environment. And when you don't have competition, sometimes timelines go to the right, costs go up, and innovation goes down. And we're really trying to fight against that to make sure that in anything that we do, we're trying to move it as competitively as we possibly can.
Hello, John. Dwayne Conley with RJ Lee Group. Great presentation.
Thanks.
And really enjoyed you highlighting what you guys are doing with the F-100. Wanted to also ask, I know you guys have been investing so much in the digital transformation for 5, 6, 8 years now. Can you highlight or maybe give some examples of how you've been breaking down data sharing barriers to help bring data together to make those analytics work better?
Yeah, we've had a couple of activities. It's been more on the reliability center maintenance side. What's wonderful about doing big data analytics is that we own all the maintenance data that goes into our system. So we have an engine management system called SIMS, and so all that data just kind of every maintenance pool, every issue we've had, it all kind of feeds into there. So the data is Air Force data on that side, and then really what we're looking for with industry is somebody to help us craft the algorithms to go back and look at it. And we've had a few instances where we've been able to fund those algorithm developments and really be able to get after using our data well and actually own the algorithm at the end of it too. So I think those types of activities are certainly, certainly help open that door up a little bit. Digital twinning does too, because then we kind of get the data, we own that data after the end of it. And then what you end up able to do is do more, repair development type of activities. And that helps open up and kind of bring some competition sometimes. So what we end up finding is that those little pockets of things tend to kind of, spiral into, the multiple avenues where other vendors can come and play, which is always of interest to us.
I believe that's all the time we have.
Okay, great. Thank you all very much.
Thank you, Mr. Sneden. Our next panel is filled with some of the best advocates for aerospace in Oklahoma. Please welcome the panelists for the Workforce Development and Innovation Institutes of Oklahoma. Lieutenant General Retired Don Wetekam, Chief Strategist, Oklahoma Aerospace and Defense Institute with the University of Oklahoma. Ms. Whitney Alvis, Dean of Workforce Development, Rose State College. Ms. Victoria Natalie, Director of Strategic Innovation, Oklahoma Aerospace Institution for Research and Education at Oklahoma State University. And Mr. Eddie Compton, Aerospace and Defense Liaison for the Oklahoma Department of Career and Technology Education, moderated by Mrs. Jennifer McGrail, Executive Director for the Oklahoma Center for Advancement of Science and Technology. Let's give them a round of applause.
Well, wonderful. Now we know we're going to try to get you out of here on time because we are what is between you and drinks downstairs. So we're going to try to keep this short and simple. But first off, we want to say thank you so much for being here with us today and letting us give you some information and a conversation on workforce and all of the different innovation programs that are going on here in Oklahoma. So just to get us started, let's let all of our panelists just give us a brief introduction and what role you're representing today.
My name is Whitney Alvis. I'm the Dean of Workforce Development at Rose State. For those of you who are not from Oklahoma and not familiar, Rose State is a 2-year community college. We are right down the street. We pride ourselves on being practically across the street from Tinker Air Force Base. We have primarily 2-year degrees. My department, our team handles everything that is not toward an associate's degree. So everything aiming toward an industry certification that a lot of you are looking for, all of K-12 STEM education, and career services for the whole campus.
Awesome.
Hi, Victoria Natalie, Director of Strategic Innovation for OAIR, Oklahoma Aerospace Institute of Research and Education at Oklahoma State University. So OAIR is a new opportunity that I get to, and honored to be a part of, where we're taking a more industry-focused look at how to provide a gap-filling resource for the aerospace industry centered around emerging aerospace technologies.
Eddie Compton, I'm the Aerospace and Defense Industry Liaison for the Oklahoma Department of Career Tech, and my job is to basically translate between the industry and education and the career techs to make sure that we're providing the workforce that the industry needs, whether that be an A&P certified mechanic from the FAA all the way down to some customized training that someone might need.
And I'm Don Wetekam. I have a couple roles at OU. I teach in the engineering college. Fortunately, they don't allow me to teach a technical engineering topic. I actually have a leadership course, and I think that's well for everyone. And also, I work with the Oklahoma Aerospace and Defense Innovation Institute, which is OU's Aerospace and Defense Research Institute. That was established 2 years ago, and I'm the chief of strategy for that institution.
So looking at the fact that we have actual innovation and industry partners, and then we have the true workforce education training, for those that are in our audience today, how does your organization go about partnering with the Air Force and the institutions in the room, and also making sure that what you are doing keeps their future needs in alignment with your mission of your organization? And let's
I
start
can
with you.
start, yeah, well, I'm ready to go. I figured you guys would shut me down because you know I can go for 20 or 30.
Whatever you want.
But, no, but our job at Career Tech is to work with the industry. I work with, let's say, particularly here at Tinker. I'm the focal point between all the schools and Tinker to make sure that we line what we want to do. Because we can develop like an aircraft electrician, and the industry might need 5 or 6 of them, but that doesn't feed what the rest of the industry does. So we try to align that and make sure we manage it in such a way that we meet your workforce needs and all the aerospace industry's workforce needs in that area. What we have also done is we reach down all the way to elementary school to make sure we do exploratory training and opportunities in aerospace. And I think if anyone's here last year, we did the 43 videos that were 3 minutes because they told me that's the attention span of a child, which they told me the teacher said that's probably giving them some. But we did those 3-minute videos to make sure that we could get out to the schools so they understood all the things. Majority of people, I wouldn't even say students, but the majority of people don't even know the FAA has a large presence here in Oklahoma City. People see Tinker and they don't realize what they do. So we wanted to get that word out and reach down. And I will tell you that we started that 2 years ago, and our registration in our A&P schools is about 3 times what it was 2 years ago. So we're growing those new aircraft maintenance technicians. We also do a lot of advanced program training in our career techs and high school students that they couldn't get from their schools, and we do pre-engineering courses so that we set them up to go to OSU, OU, OCU, and the other engineering schools and become an engineer and not a business major. So those are some of those things we do, and we're trying to reach out now into rural areas and do a program they call Choose Aerospace, where it would be a high school exploration in aircraft maintenance, and we'd cover the general aviation maintenance things on those high schools so that they could feed into an A&P school later and get a great job in aerospace.
Awesome.
Yeah, for OU, I would say the foundation of the university's partnership with Tinker really goes to an educational partnership agreement that was formalized and completed 3 years ago. In fact, we're now in the process of redoing that and revitalizing it. And I should be very specific here, that educational agreement is with the Air Logistics Complex, okay? So, but from that, a lot has grown out of it. So that EPA, as we call it, has really been the foundation, but it's gone well beyond just education, even though that's the title of it. We now have research projects that we're doing with the Air Logistics Complex, and really from that, we've grown beyond the ALC. We also have a very, I think, a significant research project we're doing with the 448th Supply Chain Management Wing. We have, and there's a lot of interest at the sustainment center level as well on what goes on. So, but it started with the EPA, and I'm very pleased with, with where we are 3 years down the road with that. Relative to industry, we have many and varied partnership arrangements with, with our defense contractor network. Obviously, being an Oklahoma institution, that kind of starts with our largest defense contractors. In the case of Oklahoma City or OU, it's the Boeing Company, it's Northrop Grumman, and others who have the largest presence here. And we have significant interaction with all of those, which goes both to the college, in the educational mission, but also to the research side.
Now, Whitney, what about Rose State, with you literally being in the backyard? Everyone else is in the neighborhood, but you're literally the backyard.
I think it's about building relationships. And so I think with our proximity, we are able to have really, really strong relationships with both Tinker and our industry partners. So we try to do a lot in collaboration. The Oklahoma State Regents for Higher Education have developed a program around micro-credentials, and that has allowed us to both co-create and even co-teach in some instances with industry partners and with people at Tinker toward industry-recognized certifications, so cybersecurity certifications, some systems engineering programs that one of our industry partners needed, some flight simulator technicians that needed some specific training and couldn't quite get past an industry test. We were able to go in and do contract classes for them So we do additive manufacturing contract classes for some staff at Tinker. I really can't emphasize enough the importance of building relationships, because if you know one another, when you walk in the room, it's pretty easy to have a conversation around what someone needs and what you can do. And if it's not you, if it's not Rose, we point them in the direction of any of these people who have the capacity to do it. So I really think the people are the way to get around filling the needs.
Awesome. I really think that it is that collaborative ecosystem that makes a huge difference, and especially if you're going to be working with a large entity like the Air Force or like any other larger group that can really use a lot of these technologies and seeing them fully developed. With OAir, we were able to build on a legacy of excellence in engineering at OSU, and some of that was based around emerging technologies. But in recognition that none of this stuff is developed in a vacuum, we've been able to actually hire full-time engineering staff, combine that with students solving problems, and kind of culminating in a couple of our centers of research. One is for the Center of Excellence for Counter-UAS. Another is our Advanced Air Mobility Center of Research. And again, in that recognition that this technology cannot be developed in and of itself, it always has to work within the larger ecosystem, and pulling all of those pieces together, that's really where we want to be situated, and bringing the new emerging technology together with traditional aerospace and this ecosystem that's already been developed is where we're focused.
Awesome. Well, this panel is primarily workforce and then innovation. And we all know that there's the big elephant in the room of significantly needing more trained, skilled workforce. I know within OCAST, we do technology-based economic development, and one of the 5 factors in states that are the most successful for innovation, number 5 literally is skilled STEM workforce. So we know that our partners in higher education do a really great job. But one thing that some of those in the room and those not from Oklahoma might not be aware is how our partners within our career tech system and our community colleges can help bridge that gap of a non-traditional skill set into professional-facing jobs. So Whitney and Eddie, can you talk to us about how the career tech system and our community colleges and two-year universities can help bridge those gaps?
Yeah. We're really nimble. I think, especially in workforce in my department, we're able to be very nimble in creating new programs. So the process for approving and credentialing through the Oklahoma Regents is expedited when it's not leading to a 4-year or even a 2-year degree. So they have recognized that industry needs some of these things, and they have really worked with us to create a pathway into being able to create programs very quickly for industry partners when they come to us and they see a gap and they need it filled. And they, Eddie alluded to it a little bit earlier, but I think Career Tech does the exact same thing, and just under different programs. We're able to create those things very quickly. And even to take things a little bit further, where Rose State has just received Oklahoma State approval for our first 4-year degree in cybersecurity. So it's still pending.